Hello, everyone. I'd like to welcome to the stage Rob. He's not too into specifics, all about generics. Please welcome him to the stage.
There you go. There you go. I don't think I'm on yet. Am I? Now I'm on. Okay, we're good. I don't like this on my shoulder. I'm Rob Napier. Let's talk about generics. In 2015 at WWDC, just right here, Dave Abrahams gave what I believe is still the greatest Swift talk ever given, but I haven't seen the Swift UI talks yet. So as of last week, he gave the greatest Swift talk ever given, and until possibly the Swift UI talks, the most influential Swift talk ever given, called Protocol-Oriented Programming in Swift, or as we like to call it, the Crusty talk, right? This is a talk that actually introduced us all to the term protocol-oriented programming. But I heard that, and I was like, I took away from this entire 45-minute talk, which I watched twice, I took away one phrase, start with a protocol. And I did. I dutifully went forward and I created my user protocol and my document protocol and my shape protocol, and then I made all of my generic, subclasses of them. And then the message. User protocol can only be used as a generic constraint because it has self or so. So I spent a lot of time on Stack Overflow, a lot of time. And probably people having trouble with this is one of the most common questions in the Swift tag. And so I try to go in there and I try to help them work through what's wrong. And what's wrong is that that's not quite what Dave said. I mean, he literally said those words, but it misses the entire point, which is, this is what he said. He said, basically, if you want to write a generic algorithm of some sort, then don't start with a class and class inheritance. Start with a protocol. Try a value type and a protocol instead. If you want to do this, right? He did not say, for all problems, start with protocol. Like before you've written a line of code, type protocol. That is not what he said. It's not what he meant. So today we're going to work through a lot of examples, particularly focused on the removal of class inheritance. Inheritance is the thing that Crusty was mostly talking about. He actually, while he talks a lot about protocols, it's really the dangers of inheritance and how we can do better. It's all about extensions. This is really the heart. I wish protocol-oriented programming is kind of confusing because it's the first protocol-oriented programming language. Go is a much more interface-driven programming language than Swift will ever be. Like, it lives and dies on interfaces constantly. But that wasn't the point. The point is really extensions, which is a form of composition. Most common time I know I'm going to get into trouble is when I start a project with the phrase, I'm going to write this as generic as possible. Once you see those words, you are on a bad road because it doesn't mean anything. There is no generic as possible. Flexibility in one direction is choices. All generic means is abstractions, and abstractions are choices. And when you make a choice in one direction, you often are making it inflexible in another direction. So you want to know what kind of flexibility you want. And if I had just one takeaway, after this slide, you can just leave. We're done. Write concrete code first, then work out your generics. Right? That's kind of it. Okay. You need a use case. You need to understand what problems you're solving. And the only way you're going to really figure that out is write some code and do some stuff and see what gets duplicated. Right? The power of protocol-oriented programming is that it lets us figure out our abstractions late. The problem with inheritance is when you write it in classes, you really need to know what your class hierarchy looks like before you can implement anything. With protocols, you can write your concrete code first and duplicate a bunch of stuff and then extract the protocols later. And that's what we're going to get into today. So I see this mistake a lot. So you want to program, draw shapes, we always do that. And so you make this shape protocol, and it has a center, and you make a circle, and it's a kind of shape, and a rectangle is a kind of shape. And then you go in and you make things with impl, right, as the implementations. If you feel that impl is the right thing to add to the protocol, you know you've done it wrong, right? And it sometimes goes the other way, where sometimes people will be shape type and shape, but that's just the same thing. The real point here is that there is exactly one plausible implementation of this. And what you're trying to build here is the p-impl pattern from C++. The p-impl pattern in C++ exists because C++ has language problems. Well, it's an old language, and there are certain things that are difficult to do to hide implementation details. Swift can do that without a p-impl. So don't remake that. It's not even particularly good in C++. What you're doing here is you're reinventing class inheritance. You're still thinking in terms of a cat is a kind of animal, and that is not what protocols mean. They are not abstract classes. Okay, so what should I do? Just make your types. I have a circle. Represent it in the most natural way for a circle to be represented. You have a rectangle. Represent it in the most logical way for that. We'll get to shapes later once you know how you want to use them, right? There will be a shape, but you'll only know once you start writing some code around these things. Okay, let's see it in life. Let's really do it. We're going to do a little example because it comes up all the time. You want to connect to a network server and download JSON because the only thing we do in mobile is parse JSON. We should just make the JSON programming language and get on with our lives. But we're just going to build one of those, and we're going to see how it all works out. So I have a bunch of types on some server, right? It's a standard REST thing, CRUD kind of system, maybe. Who cares? It's got a user. It's got a document. I like to have a couple of things. I like them to be a little bit different from one another, but they're kind of similar. They both have some kind of ID, and then they have other properties. And then there's going to be this thing, a client, that I'm just going to use to go out and get stuff from the server. And that's the thing we're going to be thinking about. Okay. Wall of text, but you probably have written this about 1,000 times, right? All I'm doing is I want to fetch a user, not a general thing, specifically a user. So I'm going to make a user request, or excuse me, an URL request. I'm going to get my session, and then I'm going to do a data task. And when you get done, I'm going to call JSON decoder and decode it. Ooh, ta-da. Did I not say I'm a professional? Do not try this at home. Fetch user. So now I'm going to write fetch document. Wow, does that look similar? Why does it look similar? Because I cut and pasted it, and I hacked up a few things. The moment you cut and paste, you feel you should cut and paste. I just found a protocol. I just found reusable code because I wanted to cut and paste. Well, what's important is wow, that's dark. What's important is what changed, right? What did I need to edit? Well, that's telling me exactly what my protocol needs to do, right? And what changed, what's different between the two is the name is different, so that's going to go away. I'll be fetch instead of fetch user and fetch document. And then I've got a type in a couple of places, and I have this little string. That's the only difference. So I could just pull that together, right? And I write fetch, and I have a type and a type, but I'm left with this little string. The problem is I said that models need to be decodable, and decodable doesn't tell me what the string is. That means that decodable is not powerful enough. I need more than decodable gives me. I need decodable and something. Well, then we lift that. We create a, we require decodable. I want to be careful here. Fetchable is a decodable. It's in order to conform to fetchable, you must also conform to decodable. This is not, even though we call it protocol inheritance, it's not like class inheritance. It's just an extra requirement. It's like you took all the requirements in decodable and also smacked them in there. And you get to count as, you are decodable. Well, you do get treated as decodable. Okay, when we do that, now we can throw that in. There we go. Now, I have this concept of fetchable. that I need to attach to my user and my document. Now, you could just stick it right here in the main implementation, but I encourage you not to most of the time. I encourage you to use an extension. Like I said, extensions are kind of the point. And what's so powerful about this is it's saying user isn't deep down fetchable. I'm saying I would like fetchability, and user can adapt to that. I haven't locked user into this one API. This is not the one way I can use user. This is a way I can use user, right? It's really separate from, it hasn't changed anything about user. And what's so powerful about that is user may not be a type I control. It may be in another module. It may be an Apple type. And this is something you could never do with class inheritance, right? I can't go in and, we call this retroactive modeling. And I can go in and say, for my purposes, I want it to be fetchable. OK, so we come back to this. And it's still really tied, though, to this URL session. I mean, that's like locked in. And that seems a really inflexible point that maybe we'd like to improve. I mean, one problem with that is, of course, this is going to be really hard to unit test, right? Because you have to go out to a real network. OK. But I really want you to get beyond the idea of protocols as mocks. So often I see, well, I created this so that I could mock it. Mocks are a terrible way to design protocols. Terrible. The reason is because the point of a mock is to have a fake object that pretends to be a real object. That means the fake object and the real object have they live in lockstep, right? And then the protocol is going to have exactly the same interface as those two things. So now you have three pieces of your system that have to evolve absolutely in lockstep with one another. Well, that's a lot of duplication, and you're not getting any power for it. There's nothing you can do with that protocol other than really this mock, right? And Swift, you get a lot of costs. You wind up with all kinds of junk where things are complicated because you have a protocol. If I want to take on that complication, I want to get more than a mock. I don't even ship mocks, right? I want complexity in my program to turn into things I ship. Give me something useful. So our goal isn't a mock URL session. Our goal is to abstract away this concept of taking an URL request and turning it into data. That's what I really want to do. That's what I'm using URL session for, and I want to do it asynchronously. So I'm going to pull that out. I'm going to say we're going to have a transport that turns an URL request into a resulting data, right? And this is something I use a lot. Now, what I've really done here is I've taken a function and I've given it context. This is just one function. So I could have just passed a closure. But instead, I've given it more context and turned it into a protocol. This is actually a very common way of thinking about things, that I can have just a function that gets lifted up into a struct or into a protocol, and we can then work with it. So I just need something that can pull this off. And what's really nice is that, whoa, that is dark. URL session can become a transport with just a couple of lines of code. They're really dark. What's so incredible, this again is that retroactive modeling. This is, I've taken an Apple class and I've said URL session is my transport. Well, that's really, really nice because now I've taken something I've said I'm going to use it in a different way. So what do? I now have my URL. I take this and I'm just going to turn it into, I just pull all that code out and I moved it over into into transport, and now I can just fetch it. Now you'll notice I have this now transport variable. So I need a property somewhere, and this is why I created client. Created client so that it could hold a transport. And I've switched back and forth. I keep going back and forth on whether client needs to be a struct or a class, and I don't want to talk about that. But here it's a struct, and earlier on I said it was a class, and that's good. So I keep changing the slides back and forth. OK. It means that the client, though, in order to create a client, I need a transport. That's kind of annoying, right? I hate to pass a transport, because I don't care. I just want the normal one. I just do the normal thing. Well, that's fine. That's what default parameters are for, right? Don't jump to, I need to make it easy to call first and then like bend everything around it. Make it clean and clear and simple, and go, well, and now I'm going to have to type all this other stuff every time. Well, if you have to do it every time, then probably we have a function. We could make a function for that or a parameter. You know, we're programmers. That's what we do. And that's all it takes. But now I want to go to something really, really interesting. I want to make a transport that wraps another transport. I want to modify transport. So I want to make here, this is add headers. It's a transport. You hand it a transport, and it adds HTTP headers to it, to any request you make. And so now I can have like my authorization key. Well, now I've lifted this up. This is totally testable, totally unit testable, right? So I haven't but if I'd done it with URL session, I probably would have created a lot of complexity that is, if I had a mock of URL session, right? You can't build this kind of stuff. Here I could take this and make a transport that takes a transport and does compression on it or encryption. I could make one that doesn't go over URL session. A big deal is maybe I want to talk to a database. All I need to be able to do is take an URL session and turn it into data, right? This all came out of a design that I had earlier for some production work where we were talking an HTTP-like protocol over a raw TLS pipe, right? We weren't using normal HTTP. URL session can't do it, right? But using these techniques, the rest of the program doesn't care. That in some cases, you're talking over this weird custom VPN system, and in some cases, you're just talking over a simple HTTP link. I want to focus on this little thing. I had this let base transport. I said base is of type transport. And this is actually kind of a problem, or it's a little confusing to people. It's not that, it does not mean that transport, it doesn't mean that base conforms to transport. It doesn't mean that what you hand it is a conforming type to transport. It means that it's really what we call the transport existential. And an existential, you'll see this word come up all the time. It is a little box around another type. And the reason that they exist, imagine I have an array of some protocol, of transports. Well, in Swift, we like to just lay them out, object, 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 object in memory. But each of those could be a different size, right? Because it's a protocol. Well, how do you deal with that? We deal with that by making a little box that has a pointer to the real data. It's a little more, it's a little trickier than that, but the concept is just a little box. So sometimes when you see the word transport, you see your protocol spelled out. Sometimes that means the protocol, and sometimes it means the protocol existential. And this is actually a little bit confusing. They were actually talking a bit about changing it so that you would say any transport. I mean, like lowercase any space transport, to make it more clear that this is not the transport protocol. It is the existential. And that's why these two things are slightly different. These are not exactly the same code. The first one says, I want to create a function that every time I pass it a different type of transport, write me an entire new function that is explicitly for that type. This one says, please take the data and stick it into an existential and then pass it to me. And then I always work on the existential. In many ways, they're kind of, for much high-level work, they're kind of the same. I tend to recommend using the second one just because it's simpler and it's kind of usually what you mean. But there are various performance and other reasons that you might switch between them. People will sometimes tell you the first one's always faster. That's not true. Maybe it is, maybe it isn't. Don't assume that just because it's more complicated, it's faster. Oh, so often. Okay, so I say all of this to bring us to this magical word that everyone will talk about nonstop, the generalized existential. All this is an existential that can handle a protocol with an associated type, so a PAT, right? So currently you cannot have an existential of a PAT. The generalized existential can. It's actually a fairly complicated feature. We almost certainly will get it. But the thing is, people think it's going to magically fix all your type problems. It will not. In fact, I bet it will be used way less than you think it will. And almost every sentence that I see that starts, once we have the generalized existential, almost certainly the next part is wrong. We'll see some of that in this. Generalized existentials will not save you from bad types. So anyway, I want to look at this. We have these two things. IDs are ints. But IDs aren't ints. That doesn't make any sense. Could you add two identifiers? Maybe. Could you divide them? That's just crazy. I mean, what would that mean? They're not numbers, right? They have none of these things. And and this means that I can be really sloppy. I could hand a document ID where I meant a user ID. That's not right. That can't be, that's wrong. That tells us that we need a type. And so how do we fix it? We lift it. We create a type called an ID, right? And so now, even though it's implemented as an integer, a user.id is not the same thing as a document ID. They're completely different types. So I really like this. But it creates kind of a syntax. It's a bit of a mess. I mean, this value colon. But we can fix that. We're programmers. We'll just we'll add an extra initializer. And now we can have a much nicer syntax. So that's cool. And then we're going to do it again for document. It's getting kind of cut and pasty here. Cut and pasty. What should we do? There's something we could do about that. Well, one thing we could do is we could pull out a protocol. That's usually my first go-to thing, is probably it's a protocol in there. And we'll make one. We'll call it ID type. And all that's doing is it's saying, I don't care what it is, right? Because maybe it's implemented. I actually had this where documents where various types in my system had started out having integer IDs, and later they had string IDs. And I had to go through the whole program. It's really annoying. Kind of led to this entire talk, believe it or not. But now, okay, that's much nicer. I now am not having to say over and over and over again, ID type has all these different values, or all these different requirements. And I can automatically throw my extra little initializer on. So that's kind of nice. The problem is, it's now a path. Right? I just created an associated type. And here's when you type the letters associated type, you need to ask yourself a question. Do I ever want to put this in an array? If the answer is yes, you're in trouble, because you can't today. Now, someday, again, generalized existentials. Maybe we'll save you. Probably won't. But if you want to put it in an array, you can't. You'll wind up with the can only be used as generic constraint. Which, again, what this is really telling you is, I cannot make an existential out of this type. That's what this message is really telling you. And you're going to hunt around, and you're going to find the word type eraser. You don't need a type eraser. You almost never need a type eraser. I mean, there are times that type erasers are really useful. They really don't come up in app-level code that often. They actually are mostly useful for like standard lib things. And even there, they're getting fixed with these opaque return types and everything else. You just don't need a type eraser most of the time. You've written this line of code, and let's pretend that you could do this. Let's say we do have the generalized existential. It comes to save us. Let me show you why it doesn't save you. I call it the what's the next line of code problem. Okay, let's pretend you have it. Let's say we want to do like refresh. We want to refresh a bunch of objects that are in our system. Great. So I want a list of IDs to refresh. Great. So what are you actually going to call? How do I know what the type is, right? Remember, each ID is a different type, and I don't know what it is. So it's going to have to return any, right? But I can't pass any. And so maybe I'm going to have some kind of dictionary where I do model type. I kind of like try to keep track of how they're related to one another. And none of this will work. When you try to write this, okay, try to write refresh. You can't. I mean, there's no code here. Instead, I go back to what did I want? Did I want a list of IDs to refresh? No, I wanted to have a list of things to refresh. I wanted refresh requests. So make one. We're going to just make a struct that wraps. Remember how I talked before about we could just have functions. We lift them into things to give them more context, more power, and that's what I've done. I just have a thing, perform, and I can now make arrays of them. And now I can just make. In this code, I actually duplicated user ID and document ID. Obviously, this could then be pulled out into a protocol and make that a little nicer. But the idea is that I can now just make things. This is type erasure rather than type erasers, right? I'm just getting rid of types that I don't care about. I hide them in the inside of a function. And then it's all, now it's straightforward. I just have refreshes, and now I can just, for all of them, perform. That's all fine. Just functions. Just functions. So now paths are very useful. The associate types, they are very, very useful. They're just not for putting things in arrays. They're really, the important part is that they give us free stuff. they give us all these extra little things. Therefore, when you make pats, the point should be to give powers, superpowers, to certain types that conform. Like, if you'll conform, if you'll do the things I ask you to do, then I'll give you this stuff for free, right? And if your protocols aren't doing that, there are kind of two kind of reasons to use protocols. One is I want a heterogeneous array, and that can only be simple protocols. The other is I would like to give you powers. I would like to put methods on you. All protocols can be used for that. And in fact, that's often the best use of, that's like what protocols are really, that's their power. It's not making an array of things. It's these ability to add extra methods. Okay, so now I had that fetchable. Fetchable now has to be able to deal with these IDs. So I threw that in, and now the fetch method takes an ID rather than an int. And whoa, I just typed the word associated type. So fetchable just went from being a simple protocol to a pat. Is that okay? Maybe? This one actually I struggled with for a while because I'm not sure if it's okay. But the thing is, you go, well, if they're fetchable, they are going to be, do I really want a list of fetchable things? And what I want you to be very careful about is don't think about it in terms of, well, fetchable things are model objects. No, fetchable things are things I can fetch. And I probably don't want a list of them, but maybe I do. And so I struggled with this a lot. And finally, it brought me around to maybe protocols. Well, this actually works. I actually ship this code I've been showing. This is all production code. I've been shipping this for a long time in several different products. It actually works great. I've never actually needed to put them in an array. It's just never come up. And I'll tell you, if it's working, it's not wrong. Never let somebody tell you, that code's all wrong. It's like, but it solves my problems, and it hasn't caused any new ones. But that doesn't mean we can't make it better. So how could we make it better? We could look at, here's one of the problems that's coming up. Fetch needs to know the model's type and its ID. Because remember, the ID doesn't actually know its own type. A user ID does not know it is related to user. That's kind of actually weird. But so in order to make it work, you have to tell any function that gets a user ID, you also have to tell it user, right? Because it's not bundled there. Now, we could fix that one way. We could put an extra type parameter. We could make another associated type called user, or called a model or whatever, in the identifier. It starts to make it gets even more messy as you do that. I mean, it'll work, but it gets even more messy. But there's actually a deeper thing. Every implementation of ID is going to look like this. There's no other implementations of it. I mean, it would be ridiculous to have any other implementation than you have a value. What this is telling us is it's not really a protocol. Protocols, at their best, have lots of types that could conform in different ways. If every type is going to conform in the same way, it's really probably a generic struct. And so let's do it that way. And I'll just make an identifier type that takes a model and a value, has 2 parameters. Now, model, you'll see, doesn't actually show up anywhere. It's not used. Its purpose is it means that a user identifier is a different type than a document identifier, even if they're both int, right? Otherwise, if you didn't have model, then all identifiers of int type would be the same type. So this separates them out. And as an implementation detail, you do need to add a codable for this, because you would like to encode it. You don't want to code it as like value in a JSON document, right? You want to just encode itself as a single value container. It's just an implementation detail. Okay, so now user becomes this. And that's pretty good, but the trouble is we now have lost the type user ID. There's actually no type for that. We have to say identifier user int. That's actually really ugly. We don't want to expose int. We don't want to force people to do int, to know that it's int. So I can fix that, though, by making a user ID type as just a type alias. And that's kind of nice. But now I'm going to want to, of course, document's going to be almost exactly the same. Everybody's going to be exactly the same. And I do want to talk about things that have an identifier, things that are identifiable. So I can create or identified. This is a thing with an ID, which is all it tells me. Just a thing with an ID. And you see now I've said the identifier is myself, right, when I create it. OK. And so user is identified. And now every line, what I love about this is every line is, in fact, critical. Right? There's no repetition here. I have to tell you it's all of this stuff is important. And then fetchable, I just say fetchables have to be in order to be fetchable, you have to be identified. Now, fetchable is still a pat. This is a good one, though. Should identified, it's a pat. Is that a problem? What algorithm would you ever write that said, you can hand me a list of things that are identified and I will do something interesting? I have no idea what they are. The only thing I know is they have an ID. What would you do with that? There's very, very little that you can do with just that one piece of information. You usually need a little bit more. And so you're usually going to lift it if you need to write a protocol. So again, having just an array of identified is probably not useful. So it's OK that it's a pat. OK. So that takes us from this, where we had fetch, and we had to say model type, model ID, and when we called it, we had to double it all up, to we just take that out. And that's nice. That's what we like. OK, new topic. So this was all great. Everything here, the only thing a client can do in the entire universe is fetch an object by its ID. Some people have APIs that do more than that. I mean, I don't know if you do, but maybe you need an API that does something more than just fetching objects. Like, for instance, maybe I want to do a keep alive, right? I need to just do this post every so often. And it doesn't return a type. It just returns an error if there was a problem, right? There's not a lot of duplicated code here, actually. There's only like one line of code, I think, here that is literally the same line. But there's still the same structure, right? I'm coming up with an URL request, I call it out to transport, and then I do stuff with the stuff that comes back. And when we see similar structures, even if it's not literally the same lines of code, it's very possible that there are things we could extract. And really what it's telling us is that fetch is doing too much. It's doing a lot of, when you start color coding it and you go, there's a lot of colors in there, it's telling you the function is probably too big. So maybe we should pull out the part that changes. And we're going to call that thing request. And this is what I kind of call wish-driven development. It's like, I wish there were something that would just know the URL request. And let's pretend it exists. And we'll get around to building it later. So now fetch just says, hey, transport fetch the thing. And the request will take care of all the pesky details of like everything else. So when faced with something like that, it's like, OK, now we need to build request. And I see people, very, very, very common, they jump to this. They make a protocol request, and they have an associated type of the response. This blows up every single time. This is probably 40% of the questions that I get on Stack Overflow is, I've done this, how do I use it? And the answer is redesign it. This won't work because, again, if you made an array of requests, you're going to want an array of requests. I mean, come on, you're going to have pending requests, you're going to have requests that need to be retried, you're going to have arrays of requests. But each request has a different response type, right? So what generic algorithm could you write that could handle any response type that happens to be in that list? Doesn't work. It's a design problem. How do we fix it? Well, I say, let's write the concrete code first. Don't jump to the why do we get in that trouble? Because the first thing I said, we want a request. Let's write a protocol. Don't write the protocol. Let's write the most concrete request possible. A struct. We'll just make a struct. We'll see if it works out. And it just has no request and completion handler. I mean, it does nothing else. But what do I want to work? I want to be able, let me go back. But there's a little trick here. And it kind of plays fast and loose. Result here takes a data, not a response type. It's just data. So that's actually a problem, because I want to be able to deal with things that aren't data. Well, how would I do that? Well, I would like to be able to, again, wish-driven development, I would like to be able to write this line of code. I would like to make a request that fetches, that makes me a fetch request. And so, okay, that tells me that there must be this thing. How would I fill that in? How would I actually make that work? Because I have this problem where data doesn't match up to model down here, right? I get a model, and I need a data. I wind up with this. I want to go from model to void, and I want you to think, when you think about to void, don't think of void as doesn't return anything. I want you to think of it as it returns void, because it just makes everything much cleaner. And in fact, it's true. There is, in fact, a type called void. It has a value and everything else. So that is really what happens. So don't think of void as like, I mean, it's real syntax. It really has a meaning just like any other type. So model to void, but I want data to void. How do I get there? I need this other thing. I need another function called data that does data to model. Why is that the function I need? And the reason is because if I put them together, I get data to model to void. You can always hide the inter type. The only thing you ever care about with functions is the ultimate input and the output. This is type erasure. I just erased the type that I didn't care about. I hid it inside of functions. They're the best things for hiding types that you don't care about. Now data to void gets me there. Okay, so fine. Algebra, functional composition. This is functional programming. This is functional composition. This is what we mean. We're taking functions, we glue them together. What did I want to say there? How do we build it? Okay. So we just turn it into it. So we take exactly, I want to do that again. We had client, had this fetch protocol. We just want to turn that into a request, and it's literally the exact same code. We don't have, you'll notice there's no associated types here. There's no protocols. It's just function. It's just structs. And the struct's not even generic. I mean, requests aren't generic. They're just straight up structs. It's exactly the same pattern. So the same pattern works with keep alive, right? And it has the same kind of type problem. It needs to return an error rather than a model. That's fine. I just make an extension on request that says, make me one of those. Because all you have to do is be able to create a type. Okay. Those are the big things. I want to talk some odds and ends. Probably the most common reason I see pats sneak into people's programs is because they throw on equatable. And
Yes.
they often don't mean to. The trouble is you have something like this. Say we have some kind of document protocol. And we have text documents and we have spreadsheet documents, right? And spreadsheets are both, and they're both equatable themselves. The trouble is then we're going to throw them into, a document is a simple, it's not pat. We can create an array of these, because we probably do want an array of documents, and that's great. But all of a sudden, we can't do equatable things. We can't write contains, right? Because document is not equatable. So, did I do it? Thank you. And it's like, no problem. I'll just add equatable. And this is where everything explodes. Bam. Protocol could not be used because you just made it a pat, right? You didn't type the letters associated type, but they snuck in on you anyway. And the problem is that how do we do it? I mean, we do want to compare documents, but I can't make them equatable. The problem is that you don't really mean equatable. Equatable has a very specific meaning. It means that something can be compared to itself as a concrete type. Protocols are not concrete types, so they can't be self. It has to be a concrete type. So that's what equatable requires. So if it means that, if that's what equatable means, and we don't mean that, what do we mean? We mean a different thing. We have a standard recipe. This has been around for years, and this is kind of the way you do it. And it's the words I kind of want people to use so that we all use the same words. Is equal to, right? We just attach that. And the nice thing is, And then, we just say, if we're the same type, then if we're not the same type, we're different. And if we are the same type, then use equatable, because we have equatable. And of course, there's a lot of duplication here, and we can fix that, no problem. We just use an extension that says anytime the type is equatable, give it is equal to for free, which is very, very nice. Now, you're probably thinking, so document, there's like whatever, 5, 6 lines of code here. This is special to document, but there's a lot of protocols that probably need a is equal to. Couldn't I lift a protocol? No. You would like to. Swift, this is a point at which you've actually run into the edge of the Swift type system. You have a thing that is a very reasonable thing to say. I would like to say that certain kinds of protocols automatically get this extension. There is no way to, and that is it's a completely legitimate thing to say. It's just Swift can't say it. The type system is insufficiently powerful. I think for this one we would need higher kinded types to pull this one off. But you would need something that is able to talk about types as types, and Swift just can't do it. So yes, you are going to have to write these 6 lines of code over and over again. In the most I think I've ever seen in a program was 8 times. It doesn't come up that much, but if it really does bother you, you'll have to use like sorcery or something. I mean, the sorcery code generator or something like that. But usually it's like, it's a few lines. Yes, it is cut and paste, and it's unfortunate, but there are limits to our type system. Okay, so now remember though, this didn't make documents equatable. They're not equatable. You can't use the regular contains. You have to use is where. We can fix that. You just make a sequence. You can make an extension so you can get the syntax you want, right? But it's not equatable. Now notice carefully though, extension sequence where element equals document, not colon document. This is not for sequences that have elements conforming to document. It is only sequences that it is literally document, the existential. Now, why did I spell it is equal to? Couldn't I have spelled it equals equals? Couldn't I have just made the function b equals equals? And I tell you, yes, you could. I mean, syntactically it works. I tell you, don't do that. The reason is because equal equals means equatable in Swift. And you're implying something that then you don't deliver, right? So I encourage you to use is equal to, because that way it is clear this is another thing that is not the equatable operator. Don't use operators for funny things. Which comes to one of the big points. Protocols are not bags of syntax, right? Equatable does not mean it has an equals equals operator. It means a lot of things. It has rules. It has semantics, right? But this is what you learned in like 8th grade algebra or 8th grade, you know all these. But this isn't really the whole story. This is actually a side effect of the real requirement of equatable. Equatable is substitutability. For something to be equatable, it means that if you give me both objects, you don't care which one I hand you back. There is no system in which you would ever care which one I gave you. So if two things only have the same ID, this is the thing, people make like equatable to mean I have the same ID, but the other fields could be different. Well, you might care which one I give you back then, right? Then that's not a proper use of equatable. Equatable means all public uses must be substitutable. And from that, all the other rules fall out of it. It's because protocols are about building useful algorithms. This was most, I think, elegantly put together by this discussion that happened in the Swift evolution world of should we have a default constructible, right? And we had this protocols, AKA concepts, which is the word used in C++, and also I think a really great name for protocols. Concepts are not just bags of syntax, right? And for the same reason, we should not have default constructible that just says there is an init any more than we should have plusable to say, well, you could use a plus on it. It's like, that's not helpful if I don't know what that is. What algorithm would you use that says, I can apply the plus operator to it, and it will do something? It's not useful. You need here default constructible. So the thing you get back from init, is it a valid value? Is it an invalid value? Is it some kind of n value, an empty value? What is it? It could be anything, right? What algorithm would you write with the result of that when you have no idea if you can even use it? This is in stark contrast to one of my favorite protocols, which is range replaceable collection, which just adds 2 things on top of collection, and one of them is init, right? A bare init. And then you also have to give this other thing. That init, however, has semantics. It is required to mean an empty collection. So it requires that if I call init and also call remove all on something else, that the 2 will be equal, right? There are algorithms now I can write based on the fact that I know what that means. And in fact, you get about 24 methods for implementing these two. You get 24 more methods. That's what you want to see in your protocols. You want to see, I have a very, very small number of requirements, and I give you a huge number of superpowers. And that's kind of the point, right? Protocols are for algorithms. They should enable us to have reusable extensions. Start with the concrete. Find your protocols. It isn't supposed to hurt.